Good morning, students. I hope you all are clear with stress and strain and the basics of rock mechanics. If any one of you have any doubt, please ask in the discussion forum. Today we will be covering physio-mechanical properties of rock. So without wasting any time, let's just jump onto the topic. Start with the physio-mechanical properties of rock. So as you all can see on screen, the physical characteristics of rock. The crushing strength. Please make a note of it. The compressive strength. Maximum force expressed per unit area which a stone can withstand. Compressive strength is nothing but the strength, the maximum strength a rock can withstand when we apply a force on it before it shows any failure. Now, what is failure? Failure can be in many forms. It be a crack or fissure, anything after which, after the application of force, when the rock mass tends to fail, the maximum the force that can be um, withstand by the rock mass is known as compressive strength of the rock. Mathematically, compressive strength is the load at which the failure occurs by the area of the cross section on which we apply the load. So there are two kinds of compressive strength, that is unconfined or uniaxial compressive strength and confined on triaxial compressive strength. Now the compressive strength may be or any property of rock may depend on many factors such as mode of formation, composition, textile and structure, moisture content, and extent of weathering. Now, mode of formation, as to how the rocks are formed. As we all know, there are mainly three kinds of rock: igneous, sedimentary, and metamorphic. So the formation of all the three kind is on different basis. Like igneous rock is formed by the hot magma when it solidifies below the crust or above the crust. Both of them yields a different kind of rock. So we'll study all. So we have studied all those kinds. So mode of formation will also uh, be responsible for any kind of physical characteristics of the rock. Now the composition of the rock, as to the rock of composed of several particles or the same particle, what kind of force is that binding the particles in the rock will depend, the characteristic will depend on that. Now texture and structure. How does texture and structure affect any characteristic of any rock? So let's take an example. If the there are spherical particle in the rock, there will be more space. So when exposed to water, it will absorb more water, it will be more porous, thus it will be of lesser strength. And when the complexity of the particles are very compact, it will there will be no space to wait, let's discuss this. How does the texture and structure hampers the mm, physical characteristic? So for example, if this is the particle of the rock, there is a certain space in between where there will be they can absorb water and become moist, and thus it will break soon or fail soon. But if the texture is in this way, there is no space left for it to absorb water or any things, as to which it will fail at a very large load. The next point is moisture content. Moisture content would be very clear to you all, where if the rock absorbs more moisture, it will fail soon. If the rock absorbs less moisture, it will fail it will fail at a greater force. Extent of weatherability means the natural forces that act on the rock, how much it is exposed to it, how much time it has been exposed to rain or wind. It will uh, it will be dependent on extent of weatherability too. Now, igneous rock, sedimentary rock, metamorphic rock. These are the three kind of rock. So igneous rock will have the highest compressive strength. Sedimentary and metamorphic rock will have the presence of plane of weakness and thus so a low compressive strength. Uh, let's discuss this. Igneous rock will have high compressive strength because there is no plane, but metamorphic or sedimentary rock, as you all know, are in layers. They are accumulated in layers. So when the force is applied, any force applied, the layers will start to break fast. So it will have a low compressive strength. The next we have the crushing strength is higher than the load it needs to withstand. Always when if we are applying a force on a rock, suppose we are applying a force on a rock, so the strength uh, of the rock would be always lower than the force that will fail the rock. So here is some examples of the compressive strength of the rock in kg per centimeter square. uh, you can see on your screen, just note it down. Now there are various measures to calculate uniaxial compressive strength, but the Thieres and Miller method is more appropriate and is taken in consideration where very high compressive strength is considered to be more than 2240 kg per centimeter square. High compressive strength is 1000 1120 to 2240. Medium compressive strength is 500 to 1120. Low compressive strength is 200 to 500, and very low compressive strength is less than 200. Now we have the next property, that is transverse strength. Capacity of stones to withstand bending load. The load will not always be perpendicular or parallel, will be having a bending load too. So the capacity of stone to withstand the bending load is known as transverse strength, and it is given by R is equal to WL by 2BD square. And always the transverse strength is 1 by 10th of the compressive strength. So the next we have shear strength. Now shear strength is the resistance offered to by the stone or the rock to shear stresses, which tends to move from one point to other, and it is given by P by 2A, where P is the load at failure and A is the area. Now the tensile strength can be tensile strength or the pulling strength can be determined by by two methods, that is direct or indirect method. Direct method is not really used, and by indirect method we know the Brazilian test by which we can take the tensile strength. Tensile strength is given by two formula, that is 2p by mu dl, where d is the dia, l is the length, and p is the load at which it fails, or p by d square into 0.0675. Now the next characteristics is the porosity. What is porosity? Porosity is the nature of the rock to absorb water. The shape, size, nature of the packing of the grain size give rise to the properties of porosity. The grain of the rock, whether to in what is the shape, the size, or the nature of packing will give rise to porosity. Why? The nature of packing will give us the information as to what space is left between the molecule or grain, and so we'll know that how much of water can be absorbed. Numerically, it is given by total volume of pore space by total value or volume of rock sample. So the numerical is very important. We'll look at to it. So the total volume of the pore space by total volume of rock sample will give us the porosity, and it is generally taken out in percentage term. Now, what is high porosity and low porosity? Which rock will be stronger? A rock with high porosity or a rock with low porosity? A rock with high porosity will always be weaker because a rock with high porosity will absorb more moisture or water, and then it will be easily breakable. So high porosity is equal to less denser is equal to lesser compressive strength. Now let me tell you one thing more about density. What is density? Density means the particle which is bit compact, as to how compact the particle is in the rock. So the lesser density gives lesser compressive strength. Okay. So we have the porosity for some rock. Granite have a porosity of 0.1 to 0.5%. Basalt has a property of 0.1 to 1%. Sandstone has a porosity of 5 to 25%. Limestone has a porosity of 5 to 20%. And marble has a porosity to 0.5 to 2%. So I have a question for you all. Among this, which is the strongest rock and which is the weakest rock? Now let's come to moisturization or the moisture content in the rock. The moisture content in the rock is given by weight of saturated rock minus weight of dry rock by weight of dry rock into 100. We'll have to remember the formula, and what is moisture content must be clear to you all. Now the permeability. Permeability is the capacity to transmit water. Like sandstone and limestone may show a high value of absorption, that is 10% or more. Pressure pressure of water not only decreases strength but also make the stone very vulnerable to frost action. What is frost action? Now, when there is a water presence in the molecule, when the rock is moist and we take it to a very cold condition, very severely cold condition, the moisture will turn into ice or it will freeze, and then when again it is subjected to heat, it will result in the failure of the rock. So the presence of water not only decreases the strength but also makes the stone very vulnerable to frost action. Now density is weight per unit volume. You should be clear with that. The next is, wait a minute. The next is density is of three types: dry density, bulk density, and saturated density. Dry density is the density of any material when it is in absolute dry state, where bulk density is the density of material where it has the natural moisture content, and saturated density is the density of the material when there is the maximum moisture content, it is in saturated condition. So we have three kind of densities, and mostly we are asked about bulk density. We'll discuss the relation between all three densities in further classes. Now abrasive resistance, qualitative then quantitative property. Resistance, resistance a stone offers to rubbing action of any kind or other. Determination of this is used where situation like rubbing by nature or artificial artificial methods are used. Now suppose we are in a road construction area where there will be rubbing of the stone with the tire or with anything that goes with it. There will be rubbing and that may result to failure, so their abrasive resistance is used. One more point is the frost and fire resistance. You are clear with the frost and fire resistance, I hope, how it is important. Now let us see to some more topics like degree of saturation. Degree of saturation is the ratio of volume of water in the void to the total volume of void in the rock sample. That is volume of water that is in the void by the total volume of the void. It is not necessary that the void in the stone is totally full, it is totally porous, it is totally saturated. So as to what level of saturation it is given by volume of water in the void by the total volume of void. Now permeability is given by Q is equal to KIA, where Q is the flow through the area in meter cube per second. Wait a minute. Let's go to permeability. Permeability is given by Darcy law. Darcy law is Q is equal to KIA. This is very important, where Q is the flow through the area in meter cube per second is the Q is the flow through the area in meter cube per second. K is the coefficient of permeability, that will be in meter per second. I will be the hydraulic gradient, that will be dimensionless, and A is the area of cross section in meter square. This is the permeability. Now any further doubt you may ask in the discussion forum, and thank you very much for today's class. I'll give you